If I stick with my notes here, we can do a good example. Let me see. Oops. Example 1. Oh, I'm going to skip this. Converting Fahrenheit to Celsius. You know how to convert Celsius to Fahrenheit? Get a freaking app, all right? Huh. Oh, I'll get to it. I'm going to get to it. We're going to go back to it. All right, don't worry about it. Yeah, if you have to convert Celsius to Fahrenheit on the test, they give you a formula, so I'm just going to go past that one. All right, what is the max? Here, this is a typical FA question. What is the max length of wire? What is the max length of number 8 wire? Max length of number 8 wire that can be used for a 28 volt system, at 50 amps. So now we're going to end up finding the length, which, like I said, I can't think of a practical application where I'd want to do that, but okay. So we're using 28 volt system, so it's the second column, 28 volt system. Max length of number 50 amps. So we're coming here to 50 amps, so it's going to be this one there. What is the max length? So we don't know over here. It's number 8 wire, so here's the number 8 right here, so we can come up number 8 until we get to this intersection right there. And what is the max length that we can use? If you can see that, you can see that? That's amazing. 30 right there, 30, so 30. So max length is 30 feet. All right. Assuming that it's not hotter than what? 20 degrees. What's 20 degrees Celsius in real temperature? It's like 70? He's right, it is like 70. It's 68. The queen is dead. We don't need to learn it now.
If we're asked a question like that, we get this table, right?
What?
If we're asked a question like that, we get this table, right?
Yes. Oh, God. No. You had better have this memorized by tomorrow. Okay. What if the max temp is 50 degrees? Now it's going to be 50 degrees Celsius. What if the max temp is 50 degrees Celsius? All right. I don't know if you can see. Can you see that?
Yeah.
I mean to make it bigger. What if the max temp is 50 degrees? All right, so we're going to use this formula. L1 is wire length calculated. Wire length calculated. L2 is new max length. And T2 equals wire temp. So what do we know? We know the wire temp, and we know what we calculated, but we don't know what that new wire length is. So in other words, we had these parameters. We figured out, well, the maximum length I could use would be 30 feet, which I guess would be fantastic if I was in the shop and I had only a number 8 wire, and I'm like, will this work? And I could do this calculation, go, yes, I can do this up to 30 feet, and I can measure where it goes and go, oh, awesome, it only has to go 25 feet, so I can use the wire. Don't have to order new wire. And I suppose that's something that would happen. So, all right, so L2 equals 254 times wire length calculated was 30 feet in our example, divided by 234, oops, I didn't put the 0.5 times T2 plus wire temp 50. So we should end up with,
19.85.
what's 7635? That times that, divided by 284.5. So L2 would equal 26.84. So 26.84 watts? Feet. So therefore, the maximum length of number 8 wire that we could use for 50 amps at 50 degrees Celsius would be 26.84 8 feet. All right, follow how to use that? Okay.
To what degree is rounding acceptable? I mean, we get dinged on it, you know, if it's 20, you cut something that's 27 instead of 26.84.
Oh, well, the questions on the test will be,
Yeah.
you have 3 choices.
Mhm.
They're far apart.
I was just thinking more real life.
Oh, yeah, I was too when you asked the question, real life. So what rounding can you do? As my rule of thumb, I just round to the next one up. So let's, for example, let's just say, we can just do a bunch of, why did you just do that? Let's just try something here. I want to erase all ink. Round something. So let's just say we had something that was 6 amps, right? Because it's in the middle of 2 thumb. Or maybe it was 5.3 amps. Well, where would you want to put that line right there? Here's the 5 amps. I'm going to say, well, it's going to be a little bit to the right. And I don't know, you want to go with something here. We'll say 14 volts, this one. We'll say it's 16.5 feet. Oh, I don't know, that's about right here. So that comes in right about here. Wow, this is just not going to cooperate. All right, what did we say? 16.5? So right there, so it's going to come. And we're looking for this line right about here. So somewhere in there. It's this 5 one right here. So we'll be right about there, give or take. So 16.5. But I said it's a little bit more than 5.5 feet. So it's, I don't know, falls right about in there. So which size wire am I going to pick? I'm going to go 16. I'm just going to always go the bigger wire. All right, so we're good how to use this. What's the temperature, max temp?
23.
How do you remember that? Tells you right there. And if you forget the formula is written right there. All right. And if you forget what L2 or L1 or L2 is, it's right here. Everything is right there. Okay. So we know how to select wire, and I just did the continuous. I mean, do I have the intermittent? Here's intermittent. It's same looking chart, right? They just move things over a little bit. So guess what? If I asked you, what is the maximum voltage drop for a 14 volt system for a intermittent load, how many volts would that be? 1. So right there. You don't have to remember. It's right there. Just have to remember where to find it. Which I used to say all the time. Being an aircraft mechanic isn't always about memorizing the information. It's about memorizing where to find the information. That's what's important. You are expected to know. All right, let's go on to circuit breakers. All right, you got to select the right circuit breaker now for the wire, because the circuit breaker protects what? Wire. So let's see. I've got 4313-1 Bravo, paragraph 11.51 says the purpose of a circuit breaker or fuse is to protect the wire. So when selecting the proper circuit breaker, do I look at the component or the wire? Right, but where did I get the size of the wire from? From the component. So if a component's got X number of amps and it's a certain feet run, then I'm going to select the right wire. Then I'm going to go to my circuit breaker section and say, okay, I've selected the right wire. Now let me select the correct circuit breaker. B, electrical wires. Electrical wires must be protected. Must be protected with a fuse or circuit breaker as close to the bus or power source as possible. I do write it. All right. 4313, table 11.3 can be used as a guide. Is that the right number? I think it's not. About to find out. Nope, because 11.3 is that one. I knew it. There we go. Oh, it is 11.3-3. I don't know how that happened. Table. Oh, that was figure. Sorry. That one's a figure. That one's table. So I knew 11.3 was something we've seen before. I'm going to come right back to that. Circuit breakers are not to be used as switches. Are not to be used as a switch. This is a rule I don't like right here. If an aircraft uses fuses, FAR 91.205 requires pilot to carry one spare set of fuses or 3 spare fuses of each kind, or 3 spare of each kind. That is required. And last point, starter circuits. Do not use fuses or circuit breakers. So if you want to wrench on that starter, you can have at it. She'll go till she melts. All right, this chart is not real hard to use.
I have a question about E. You said if an aircraft uses fuses,
Yep.
it requires pilots to carry one spare set of fuses or 3 spare of each kind.
So if I had like a 1, a 2, and a 3, I had to carry 1, a 2, and a 3. If I had a 3, a 3, and a 3, can't have 1, 3. You gotta have
3. Got it.
3 of each. So right, so we looked at before, and we ended up with what size wire did we use for that last example? 8. Fine. We used number 8. So number 8. What size circuit breaker do I need? 50 amp. What if it's a fuse? 50. All right. So if I have an 18 gauge wire, it should be 10 or fuse 10. Here, this one's different. 10. Oh, that one, next one's different. They get a little different. I just picked all that were the same. So.
Smaller the wires, smaller the breaker.
Yes, obviously. So you guys in class have a 2 amp and a 5 amp. So your 5 amp would be good for a 22 gauge wire. So there you go. Copper wire. Yep. It says down here the mil spec mil. That's the fuses. Sorry.
Number 4.
4. There you go. All right. Switches. So we know how to select wire. You know how to select a circuit breaker. But you got to be able to select a switch. It's more than just double pole, double throw, single pole, single throw. You got to have one that's rated for what you want it to do. So switches must be capable. Of carrying the load. Now, if it's much of a load, don't run the load through a switch. You run it through a relay. Switches are rated to both voltage and current. The nominal rating of the switch is printed on the switch. Printed on it. And this is the max current the switch can continuously handle with contacts closed. Current the switch can continuously handle with contacts closed. If they're closed, is the component on or off? On. All right, so here's where it gets really critical. Some loads are higher at startup. Some loads are higher at startup. Give me an example. A motor. So you guys are doing your motor. One of the last things I ask you is, hey, what's the amperage of this circuit? And you see the needle go all the way to one side, then slowly go back down. So, and keep in mind that the Simpson meter is slow to react to that. So you have a huge amperage spike in motors until they get operating. So motors, incandescent lights, they're going to all do that. So you have to derate the switch, which is not to say you put it down, but let's see. Some loads are higher at startup. So switches need to be derated for these applications. So incandescent lights, motors, or inductive circuits. What's an inductive circuit? A coil.
A motor.
Motor's an inductive circuit. It's the best one. That's why I couldn't think of the other one off the top of my head. I'm like, oh, motors. Inductive circuits. So let's think about that little project that you guys have with the motor. It's a big project to you. How many of components on that fall under 1, 2, or 3? All of them? What are all of them? You're right. The lights, the relays are inductors, and the motor. Nope. So circuit breakers wouldn't.
Even the wires are to some degree.
To some degree, at startup. At startup on it, we'll learn that later on a DC circuit at startup. Well, actually, they have a resistance. So, let's see. This note here: do not use AC derated switches. So do not use AC derated switches. In DC applications. Make sure you're using the right system. All right, so table 4313, table 11-4 shows derating chart. Mm. 11.4 derating chart. So all right, so we have a 28 volt lamp, that draws 5 amps. So how would we do this? First of all, we're going to find the right thing, 28 volt lamps. That'll be the first one right here, 28 volt, motor, heater, relay, lamp, 28 volt lamp, and the derating factor is 8. So we have to derate it by a factor of 8. So normally, if it wasn't one of these components and it was 5 amps, then we would just go to this other chart and say, well, what wire did we use? And pick the circuit breaker. But this time we're a little bit different. Say the lamp is 5 amps. I wonder if we could do that. Assuming it was a 5 amp load, which wire would you have chosen? 22. Working off this chart, that would make sense. So you would have picked a 5 amp breaker. Yep. Okay. But now we say, whoa, wait a minute, it's a lamp. Derating factor of 8. So we got to multiply that 5 times 8. We get 40. You're going to screw my head, man. 40. So we will now select which circuit breaker? 40. 40. Circuit breaker, 40. And we're picking circuit breaker, not wire. So we're going to pick a circuit breaker. Well, wait a minute here. This doesn't make any sense. So you're telling me I selected a 22 gauge wire, and I did. And if I look up in the chart, this chart here, and it says I got a 22 gauge, I should have a 5 amp circuit breaker. Yep. Everybody agrees with that?
Yeah.
But now I'm telling you, well, wait a minute. It's a light bulb, so we better go to a 40 amp circuit breaker. Well, what about the wire? The wire is not going to take much more than 5 amps, so now I got to get a new wire. Well, no, the chart when we selected the wire said nothing about it being a lamp or an inductive circuit. It said how many amps, how far are you going to go, what's the temperature, there you go, boom, you need a number 22 wire. And we said, all right, 22 wire. And then we go to this chart and we go 22, I should have a 5 amp circuit breaker. Cool, put in a 5, oh, wait a minute. Something about being a lamp. So you turn the page in 4313, it goes, oh, that's lamp, 8. So I got to go 40. Well, how in the world can we have a 40 amp circuit breaker on the same wire? And a minute ago we had it at 5 amp on the same wire. So how does that work out? Why can I do that?
Is that jump in amperage only very, very short?
There you go. Very quick. It's done. So if you had this 5 amp breaker in there, it's going to sense that and trip every time. So you have to placard it. In order to use this light, make sure you hold in the circuit breaker. Right? But you don't have to hold it in for very long. It's just once it gets running, it'll be fine. But you know that you can't do that. All right. Let's see. What do I have here? What's the largest motor? What's the largest motor a 28 volt 10 amp switch can handle? That was a terrible question. All right.
You said a 10.
What's my D rating factor?
3.
3. Okay, so D rating factor is 3. So we're just going to run it backwards. So instead of multiplying it by 3. So the question was, again, what is the largest motor a 28 volt 10 amp switch can handle? Why you'd ever do this, I don't know. So if you have a D rating factor of 3 and we ended up with a 10 amp, we got to go backwards, right? So divide by 3, what did we get? 3.33 amps. So that'll be the largest amperage we could get on that. So what size motor is that? 746 watts equals 1 horsepower. 28.
What's your efficiency?
100%. Make it simple today. So how many watts did I have?
3.33 times 28.
Yep. 93.33 watts. And how many horsepower is that?
7.6 divided by 93.33.
Yep. Well, the other way around.
1.7.
1/8 horsepower. All right. If you got that, congratulations. You're ready for the test. All right, since I'm running out of time, I guess I better speed things up a little bit. Switch material. This table shows the acceptable switch material. Lower voltage, lower amp switches have more expensive material. So bifurcated gold. So if you have a supply amp of 1 volt, and very little amps, you get bifurcated gold. Bifurcated means cut. Gold or bifurcated, then gold or silver, then, 3 volt, 30 volts, 1 amp, you just buy the cheap stuff. Why do you think it's the smaller the load, the more expensive it is? More precise? Why do I need it more precise?
You're dealing in very small numbers.
Very small numbers, so a little bit of resistance really adds up. Well, I shouldn't say that. If you have very small voltages and you have resistance, you're not going to get through. So you want better stuff. I'll say it like that. All right. Is this on your Q&As? No. Sorry about that.
So which one's the switch?
I don't know. All right, terminal ends. I don't think I have enough time to write a bunch of notes about this, but these are your terminal ends. And note that they're actually color-coded. And they should be mil-spec ends. There's a difference between automotive and mil-spec for sure. One thing I've noticed that mil-spec is almost always a translucent. You can see through the coloring on it into the wire. And we use crimpers that are nice. If we had time, there's a video. You can appreciate her nice nails. But how did I suddenly get behind on everything? But it double crimps it. How long is this video? 6 minutes. It's worth
Hi,
it.
this is Jenny. I'm an avionic.
I just got to turn the volume on.
Hi.
Hi.
Hi, this is Jenny. I'm an avionics tech at Steiner. And today we're going to go through some basics of terminal crimping. We do this daily, and some of you home builders, it may be a new skill. We're going to save you some of your supplies that get sacrificed to the learning curve. Hopefully we can keep that to a minimum by giving you the basics here. This is the standard crimper that we have at Steiner, and so that's what I'm going to show you. There are different models available out there, but this is a sturdy, good quality
Somebody look up the price on this.
crimper that we use daily and have good luck with. So you can see the jaw here has a red, a blue, and a yellow. And those are designate the sizes of your terminals.
Somebody looking it
See,
up?
there's red, blues, and yellows
45?
of the
Really?
terminals for the different size wires.
I've seen them as much as like 200 or 300.
I'm going to show you on a yellow, only because it's bigger and it's easier to see what's going on. It's going to be a little harder to crimp, but we'll get through that. The jaws are different on the front and the back. I'm going to show you it's important that you know the difference and what they do. That's a source of confusion for some. You'll see, this will be the front side. It has a flat, a curve, and a flat. And of course it gets smaller with the different sized grooves here. The top, same thing, a little smaller, a little harder to see, but it's a flat, a curve, and a flat. The back side is different in that you'll notice how it's just a smooth curve. And the top is a very shallow, smooth curve also. So there is a difference, and I'm going to show you what that does in the crimp and why there is that difference. With the yellow, I've got a 10 gauge wire. I've got it stripped back just enough so when you put the wire in the barrel, it will just protrude out the end. Not too much. You don't want it sticking out into the terminal end here. You're going to be putting a bolt and a nut or whatever. You don't want to get it in the way. So keep that right at the edge. It won't go any further with it this length because you'll see a groove right in the center of the barrel here, and it is catching the insulation there, and so it won't go any further through. And that's about what you want to see when you strip the wire back for your connection here. We'll show you how to line up the terminal in the crimper. Place it in the jaw that's appropriate for the size terminal that you have. This would be yellow. Put it in the yellow space. The back side here, you want to make sure that it's lined up flush. That you just have a little bit of the barrel showing out the back side. Out the front, you'll see just the plastic part of the barrel showing, and that the whole metal barrel is completely inside the jaw, and that's what you want. Alright, hold that in place while I put the wire in, and you'll see that it is again just sticking out the back side, just enough to see it. And to crimp these larger gauges, I will press it against the table a lot of times, so that's what I'll do here. You can hear it ratcheting as it's getting tighter. And that last ratchet will then release it. Alright, and what we have, what we do in the back side with the smooth curve, you'll see it crushes the barrel around the wire evenly. And on the other side, you'll see that it has encased the insulation, but not gouged into it, it hasn't crushed it. And then it pinches on either side of it. Okay, and that is what you want to see in a crimp, and that is the difference between the front and the back. I've got one that I crimped earlier and cut away the yellow insulation so that you can see it a little bit better what it's actually.
All right, running out of time. All right, so like I said, they're color coded. So red is going to be 22 to 16 gauge. Red, 22 to 16 gauge. Blue is 16 to 14 gauge. And yellow is 12 to 10 gauge. These terminal ends, you have a max of 4 per lug. I have a picture of that. Let me see. There we go, 4. It's not supposed to put more than 4 on there. Although I've talked to avionics guys who don't like to split them up, they'll put way more than 4 on a ground, because they say if you put grounds all over the place, you can get this thing called a ground loop. We actually get voltage running around these grounds, which is kind of a weird thing, but so no more than 4 per lug is the answer on the FA test. And check terminal strip to make sure the studs do not rotate. So these studs are sunk into this phenolic block here. Phenolic's like a plastic stuff. Or they're bolts from the back side that are, the bolt heads are captured. So those studs should not turn. All right, use the proper crimping technique. Technically, crimpers are supposed to be calibrated. And the nice thing about, you can saw that one, it put a double crimp. So it crimps at one on the shielding. So when you're pulling the wire, it's actually grabbing the shielding and the wire. And avionics guys, the good ones, they will crimp, they will solder, and then they'll put heat shrink over the top of it. They never use just strictly mechanical. I do, but let me see. What else we got? Got that. Got that. Got that.
Can you show the notes for the terminal again? The terminal is. Thank you.
I seem to recall reading somewhere that there's something about do not solder terminals. That is not a good idea.
Man, all the good avionics shops insist it.
Yeah, I can't remember exactly where I read it.
Yeah, one of the Q&As does say that. It just says crimp only.
Yeah.
Yeah, it's crimp only. Yeah.
Wow. I don't have a problem with crimping.
Wonder if that's because of safety equipment.
Some of these, though, like this big one over here, the really big ones don't have any plastic on them. So, heat shrink or a boot, there's so much to talk about. Let me see. Grommets, lace bundles, soapstone, conduit, bonding. Whew. Cannon plugs. I think one of the tests talk about which one is the positive and which one is the negative. So if you had a power coming in, see these pins fit into that right there, right? Which one would you want to be positive and have power attached to it right now? Which one would you want the ground to be on?
Female,
You'd want the power here, right?
the one from Mexico.
Yes, the one from Mexico. Why? Because if you drop a wrench on top of that, you got nothing to worry about. If all of these are hot or some are hot and some are ground, you're going to have a little welding project going on there. So not good. Yeah, cushions. And I don't think I have time to talk about that. We talked about that. Okay. Let's see how well I did here. Multimeter is put in position for measuring voltage.